So, any prediction problem, the first thing I have to do is what? Peter? Right, I got to know what kind of reaction is going on, because that influences what I'm going to write on the other side. All right, so in number 5, I have two elements reacting with each other. Two elements reacting with each other is what kind of reaction, Aiden? Synthesis. Okay, so in a synthesis reaction, I put these two things together to form a single compound. So that'll be Be with I. Now, is that an ionic compound? It is, so I need to swap and drop it. Okay, beryllium is a +2, iodine is a -1, so this is going to be BeI2. Right, and then it's balanced. Okay, because there's two iodines on each side, one beryllium on each side. Okay, if it was fill in the blank, they'd all be ones. Okay. All right, for number 6, I have a metal, an element, a metal, reacting with an ionic compound. Okay, Sadie, what kind of reaction is that? Single replacement, right. Okay, so in a single replacement reaction, I have to switch the things that are alike. Potassium is a metal, iron is a metal. That means iron will end up by itself, and potassium will end up with oxygen. Okay, now we said, in single replacement reactions, we have to check the most things, because there's a possibility of producing a special element by itself. That didn't happen in this case, okay, because iron doesn't come as a 2 or a 4 or whatever. Okay, it does, however, produce an ionic compound, and that needs to be dropped and swapped. All right, so we have, this is a -2, this is a +1, so we're going to have K2O, okay, as our compound over there. Now I need to balance. Only thing right now that's out of balance is what? Is potassium. And I'm pretty sure that a 2 there will fix that problem. Okay, everybody with me on that one? Okay, like I said, single replacement are probably the toughest ones, simply because you have to check for the most things. Okay, number 7. Ionic compound reacts with ionic compound. Emma, which kind of reaction is that? Double replacement. Okay, in a double replacement reaction, we want to make 2 new ionic compounds. And the easiest way to do that is to switch the metals. All right, so that means that copper will end up with chlorine, and magnesium will end up with sulfate. All right, so I've got 2 ionic compounds over there. They both still need to be swapped and dropped. All right, now, copper on this side had what charge? 2, right, because sulfate is a -2, and they're 1 to 1, so this has to be a +2. All right, that's important to find out because I got to know that for this side. Okay, so -1, +2, and I've got CuCl2 on this side, and then I've got MgSO4 here. That's +2, -2, so that compound is fine the way it's written. Now I need to go back and balance. Done, because it's already balanced. Agreed? 2 chlorines on each side, 1 sulfate, 1 magnesium, 1 copper. All right, does that one make sense to everyone? Okay, double replacement are probably the easiest, really. Okay. Sadie. No, makes no difference which one of those compounds comes first. Yeah. All right, number 8. I've got a carbon and hydrogen containing compound reacting with oxygen. Everett, what kind of reaction is that? Combustion, right. And the products of a combustion reaction are always what, Mitchell? Right. Okay. What do we have to remember about combustion reactions? In what order do I balance them? Okay, and there's another rule that applies here, and that is? Right, the rule of 2. Even carbons, put a 2 here. All right, 2 times 4 is 8. So there's 8 over there. 2 times 10 is 20. So 10 times 2 is 20. Right? 8 times 2 is 16 oxygens, plus 10 more is 26. 13 times 2 is 26. Okay, is that one all right with everybody? Okay, other than having a couple of strange balancing rules, combustion reactions should be pretty easy. Okay, because the products are always the same. All right, for number 9, I have rubidium phosphide all by itself. Lucas, what kind of reaction is that? Decomposition, right. So in a decomposition reaction, okay, I'm going to have rubidium by itself and phosphorus by itself. Now in a decomposition reaction, you are highly likely to produce a special element. Are there any here? Which one? Phosphorus. Phosphorus comes as a 4. And anytime phosphorus or sulfur are involved in a reaction like this, you're going to get big balancing numbers. All right? So I got 4 phosphorus over here. I should go over here and make sure that I have 4 phosphorus on this side. How many rubidium does that give me? 12. Okay? So don't let big numbers intimidate you. They're going to happen in reactions like that. Okay. Now, that said, if I could reduce all of the numbers, should I? Like if my numbers were 2, 4, 6, should I reduce those? Yes. Okay? Always reduce your balancing numbers to the lowest possible terms. All right? In this case, they're already reduced because P4 was a 1. Okay. All right, and our last one. 2 ionic compounds. Hannah, what kind of reaction is that? Double replacement. All right, so in a double replacement reaction, we'll swap the metals. That means that lead ends up with phosphate. Okay, and cobalt ends up with chlorine. Now, this is probably as difficult as a double replacement reaction would get because both metals are multivalent and there's a polyatomic ion. Okay, so if I want to figure out how to swap and drop lead phosphate, I got to know which lead it is I'm dealing with. So I go back over to this side. Which lead am I dealing with? Lead 2 or lead 4? Lead 4, right? If this is a -1 and there's 4 of them, this had to be a +4. All right, so this is +4. Phosphate is -3, right? Yeah, okay. So we go Pb3, okay, PO4, 4. Right, so that's a bit of a mess, right? But that's what we got to do for that swap and drop. Okay, and then for cobalt, okay, phosphorus we said is a -3, so that's 6 negative charges, right? That means cobalt had to be a +2 on this side, so we're going to have COCl2 over here. Now we got to balance. I got 4 phosphates on one side, and I've got 2 over here. What's the lowest common multiple? 2. Okay. Well, actually, 4. Lowest common denominator would be 2. Lowest common multiple would be 4. All right, so here I need to put a 2. Okay, that gives me how many cobalt? 6. All right, so I go over here. I need to put a 6 there, which gives me 12 chlorine. Okay, so if I go over here and put a 3 there, that gives me 12 chlorine and balances my lead. Okay, is this making sense? Ellie. Oh, because it's a little o, not a capital O, right? Yeah, carbonate is what you're thinking of, right? Carbonate is C capital O3. This is, yeah, my writing's bad, C little O3, cobalt, yeah. Okay, plus you would never see a polyatomic ion listed first unless it was ammonium, right? Okay, all right, how many people got done that worksheet from yesterday? Okay, including all the predicting parts? Okay, so not many of us, so some of us still have some work to do on that. Okay, I have one sheet that's all prediction, okay, that is coming up, okay, but I would like to go over any that gave us trouble from the worksheet yesterday, if there are any. So have a look at your worksheet right now, and if there's any that gave you trouble, let's go over those first. Okay, guys, question came up again. What do I do for naming, like on number 6 here with 6 carbons and 14 hydrogens? Again, you can just write fuel for that when you're writing it out in words, but realistically, the way that you name hydrocarbons, at least this kind of hydrocarbon, is you use the same prefix that you would for whatever number comes first here, and you add ane to the end. All right, so this is hexane. Okay, if it was C7, it would be heptane. If it was If it was 8, it would be octane, non-ane. Okay, everyone follow me there? That's kind of how you name those. Propane. I know that doesn't fit because it should be triane, but it's propane. Okay, methane, butane. And then after that, after the first 3, it follows. Okay, because then it's pentane, hexane, octane. So if you're looking for something to write other than fuel, that's kind of the naming rules. Okay. Okay. Just want to go over a couple here, guys, on this worksheet here, the one I gave you today, because I have quite a few people asking about 6 and 7. Understand that I would never give you one like 6 and 7 on an exam, okay? But it's good sometimes to challenge yourself, especially if you're just getting a little bit cocky about your abilities, okay? It's always good to be humbled a little bit, right? If you play golf and you would play from like the, the middle tees all the time and you start to feel good about yourself, play from the back tees, okay? And then you don't feel so good about yourself anymore, and you can still get better, right? So that's what we're doing here. Is these are, okay, a little bit tougher. See if they challenge you a little bit, all right? Now, suggestion on these is really do the same thing we've been doing. Pick something that's present in a large number and balance it first. Okay? On this one, though, in fact, on both of these, what you have to be aware of is the ammonium in both breaks up. Okay? One of the hydrogens is lost, okay, to something else. Where in both of them does that hydrogen go? Oh, thank you. Awesome. Thanks, Riley. Yeah. Okay, so the hydrogen from the ammonium goes where? Right here, right? To water, all right? Because we had OH in both of these reactions, and now suddenly there's an H with it. The only place that H could have come from was from the nitrate, right? So that's what we got to think about is I got to total up those hydrogens that were in ammonium, okay, and make sure that they're balanced. Right now they are balanced, right? There's 4 on both sides, okay? 4 on both sides. The problem is that some of our other things are not in balance, and they'll have to be changed, okay? I would suggest that for this one, you start with chlorine, okay, when you're balancing it, and I would suggest that with this one, you start with sodium. Okay, again, the things present in the largest number, right, are always the best ones to start with. Guys, for number 6 there, a few people have been having trouble finding molybdenum. Okay, molybdenum is number 42 on your periodic table. Okay, so if you're looking for that when you're stuck, you can't find it, its abbreviation is MO. Okay, and it is number 42 on the periodic table. Okay, there are 2 correct answers for 1 and 2. Okay, what I have in my key is this: K is added to HOH. Okay, which produces KOH and H2, okay, and then you got to balance, so you go back to here, here, and there, okay, and then it's balanced. But you could also write it like this: K plus H2O, in which case you would do a single replacement reaction that would end up with K2O, okay, plus H2, which would also be right. Okay, so there's 2 possible correct answers for that one, and the second one works exactly the same way. If you write water as HOH, you're going to get that the products are CaOH, 2, okay, and H2, whereas if you write it Ca plus H2O, you're going to get CaO plus H2. Either one is fine, okay, because theoretically they could both happen and probably do. All right. Okay, in case you're getting to the end of that sheet I gave you today, okay, the key got cut off, okay, so for this one here we've got lead 2 nitrate, that's Pb bracket NO3. 2 is mixed with potassium iodide, Ki, okay, and that gives you lead 2 iodide and potassium nitrate. Okay. Incidentally, that'll be one of the reactions that we do in the lab.